In this class, I will introduce you to Hibernate, which is used in a lot of Java applications. Hibernate is a pure Java ORM tool. ORM stands for Object Relational Mapping. So what is it mapping? It is mapping your Java objects to relational tables in a relational database. And there are different kinds of ORMs. One is Hibernate, which is an open source ORM tool, and then you have Kodo and TopLink and so on. So Hibernate helps you to persist the Java objects in memory to rows in a table in a relational database. So it has a Java API for doing CRUD operations. CRUD basically stands for create, read, update and delete. So you want to create some rows in a table, you want to update some rows in a table, or delete some rows in a table, or read some rows from a table. Those are CRUD is an acronym for create, read, update and delete. And Hibernate also provides an API to express queries referring to Java objects. And it also provides a lot of optimization facilities like lazy loading, dirty checking. Lazy loading means when two objects are associated with one another, like let's say if you have an object A which is associated with object B. Object A is using object B, but when you load object A, you don't load object B till you actually need object B. So anything which is associated or related will be loaded only when it is needed. So if A is referring to B, B will not be loaded till A actually uses B. Okay. So why do we need Hibernate? What are the benefits of Hibernate? One of the important benefits is it leads to improved productivity among developers. So it provides a high level object oriented API. Object oriented is always a good way of designing stuff. You write less code because Hibernate does a lot for you. And as a developer, you write very little SQL. Hibernate generates all the SQL for you. And then another important benefit is improved portability. Portability, what portability means is once you write the code in Hibernate, the SQL that it generates, it can generate SQL for different kinds of databases like Oracle, MySQL, Sybase and so on. Whereas if you write your programs with if you write any native SQL, then your SQL is specific to a certain database. You are tied to a database vendor. Whereas with Hibernate, it will generate the SQL depending upon what database you are using. So it is configurable to select the database for which the SQL needs to be generated. And it also provides improved performance because it does a lot of sophisticated caching and lazy loading and eager loading. So how does Hibernate work? So basically what you do is you map pojos. Pojos are nothing but plain old Java objects or simple vanilla Java objects with no dependencies on any external jars. It does not depend on any application server. You can run a pojo within a simple JVM. You don't need anything else for pojos. So you map your pojos to relational database tables using configuration files called Hibernate mapping files. So now what happens is the class of the pojo maps to the table. So all the attributes of the Java class will map to the columns of the database table. So the Java class maps to the relational database table and the columns of the database table will map to the attributes of the class. And this mapping is specified in the configuration files called Hibernate mapping files, and they have the extension .hbm. So the Hibernate mapping files, they map the Java classes to database tables. They also map the class attributes to the columns of the table, and they map relationships between Java classes and the tables. And these relationships could be like one to one, one to many, or many to many. The Hibernate configuration can be done in two ways. One is declarative and the other is programmatic. In the declarative way, what you do is you use an XML configuration file called hibernate.cfg.xml. So it's a Hibernate configuration XML file. Okay, and what do you do in the Hibernate config XML file? You configure the session factory, the Hibernate session factory. I'll come to that a little later with the following information. The JDBC connection configuration. What is the JDBC URL? What is the JDBC username, JDBC password? That is the JDBC connection configuration information. Then the SQL variant to generate. Do you want to generate SQL for Oracle? Do you want to generate SQL for MySQL? So this is what portability comes in. So in this configuration file, you specify which database you are using, and Hibernate will generate the SQL for that database. Then if you are using database connection pools, you can configure those connection pools as well. And then in this configuration file, you list out all the mapping files which you are using in your application. These are the Hibernate mapping files which map the Java classes to the tables in the database. And finally, you can specify that you want to create the database schema from the mapping files. Database schema is the table structure of all the tables in your database. So let's say you're working on a new project and you don't have a schema ready, but you can create all your Java objects and map them to your tables in the Hibernate mapping files and say create schema in the Hibernate configuration file, and it will generate you the schema. It will generate you the SQL code that you can run to generate your table structures. However, this is optional. You don't have to use it. If you already have a schema, then you don't need to do that. So the core interfaces in Hibernate are, these are the 5 most important interfaces. The session factory. The session factory is actually configured in the Hibernate config XML file. And then you have the session interface, the configuration interface, the transaction interface, and the query and the criteria interfaces. So what is the session factory interface? So every application which is using Hibernate, it will obtain a session instance from a session factory. And in your application, there is usually just a single session factory, which is created when the application is initialized first. This session factory, it caches the generated SQL statements. So when you cache something, you can reuse it. So it improves performance. Caching always improves performance. And this cache data that has been read in one transaction can be reused in another transaction, so that your performance gets better. And the way you get a session factory is you say configuration.build session factory, and that will give you a session factory object. And generally in an application you'll have a single session factory. And from the session factory you can open a session. You say session factory.open session. Okay. So this session is a main interface that is used in your application. It is a single threaded object, and it is a short-lived object, and generally it is used in a transaction context. It represents a conversation between the application and the database. And using the session, you can create query objects which can retrieve the persistent objects. The session basically, it wraps a JDBC connection, and using that connection it can interact with the database to do queries or to save or to update or to delete. And it also holds what is called as a first level cache of all the persistent objects. So this cache helps to increase performance. So the general usage is you load the Hibernate configuration file, the hibernate.cfg.xml file, which will create a configuration object. From the configuration object you can get the session factory, and from the session factory you can get the session. And once you get the session, you can run your Hibernate queries to retrieve data from the database, and that data gets mapped to Java objects by using the Hibernate mapping files. In the mapping files you specify how each column in a database table maps to an attribute in a Java class. And this HQL is nothing but an object-oriented extension to SQL. It is very much like SQL. So if you know SQL, it is very easy to learn HQL as well. So let me show you some simple examples of the Hibernate config file. So here I have a Hibernate config.xml file, and it starts with the tag Hibernate configuration and ends with the tag Hibernate configuration. And inside that you are declaring a session factory. And inside the session factory you specify all your JDBC parameters like the JDBC driver class, the URL, the username, the password. And Hibernate.dialect, a dialect means like one language can be spoken in many dialects, like, right? So similarly, if you say that the dialect that you want Hibernate to use is MySQL dialect, that means all the SQL that it generates is for MySQL. If you want the Oracle version of SQL, here you'll say Oracle dialect. It is all SQL, but there are minor variations between one database to the other database. So Hibernate will take care of that for you. So it improves your portability. So you can easily switch from one database vendor to another database vendor, all by changing the Hibernate dialect here. And if you want to see the SQL that is being generated, this is like a diagnostic tool. If you set it to true, you can go in the Hibernate log files and see all the SQL that it generates. This is useful when you are doing debugging or in development. And then finally you list out all the mapping files one by one. So let's look at the stock.hbm.xml file. HBM stands for Hibernate mapping. It's a short form. So in the stock.hbm.xml file, you'll see that it starts with the tag Hibernate mapping and ends with the tag Hibernate mapping. And here you're saying my class name is a stock class, which belongs to this package com.zenvelocity or training.hibernate.mapping, and it is mapped to the table called stock in the database. Okay, now let's see all the different tags that are here. There's a tag called ID. ID means it will uniquely identify a row in a database table. So it's like the primary key in the database table. And the name of the attribute in the Java class stock will be stock ID. And that maps to the column called stock ID in the stock table. And here it says the generator class is identity. That means the database will automatically generate whenever you insert a new row in the table. It will create a value for this. You don't have to specify a value. So the database will ensure that each row in the table is unique. And then you have a property called stock code. It is of type string and it maps to the property to the column called stock underscore code in that table called stock. And here you are saying that the length is 10, it is not null, and it is unique. The stock code has to be unique. So if you are storing stocks in a table, you want the stock code to be unique, right? And then you have the property called stock name. It is a type string and it maps to stock underscore name in the database table. And then you have other attributes like length, not null, and unique. And then if you see the stock so the stock class has a stock ID, stock code, and the stock name. That's what we had here, right? Stock ID, stock code, and stock name. And if you go into the database, you will see that there is a table called stock. It has a stock ID, stock underscore code, and stock underscore name. Let me quickly check that. So in the database table, I have that columns called stock underscore ID, stock underscore code, and stock underscore name. And that's what we were referring from the Hibernate mapping file. So in this class, I introduced you to Hibernate. How do you create the Hibernate configuration file? How do you create the Hibernate mapping files? So in the subsequent classes, we'll go into more details about Hibernate.